actually, my co-author and I would like to thank the support from the HHS regarding the issues of this paper. And for the work itself, is actually really something very simple, really. I feel feeling embarrassing here. And so actually, in one sentence, this works about building a typeset Haskell interface for Redis. What is Redis is an in-memory data structure store, which is popular recently. So actually, tell about what Redis is. As I said just now, it's called a data structure store. I think when they use terminology, I think I refer to something that's not a full database, but something that stores data which you can query and alter. So basically, it maintains. You can think of it as something that maintains a set of pairs of keys and values, and to which you can ask what value a particular key is associated to, and then alter that value using various functionalities. And it's a very simple concept, but somehow the concept is quite useful. So that as far as I know, it's been used in a number of well-known services, including Twitter, GitHub, etc. So now this is the sample, very simple sample Redis session in which the first command is add, where s means set, add something to a set. And then in this example, the set is called sum set, and then you add three elements, A and B and C to it. Then the command succeeds and the system returns true, which is the size of the set now. And then you add two elements, A and B, to another set by the same command as add. And then afterwards you can take the intersection. And then the system replies what the intersection are two elements, A and B. Actually, there is already a Haskell interface to Redis, a very popular one called Redis. And you can do everything you can do Redis in a similar way in a Haskell interface. So you can also add something to a set and add something to another set and take the intersection. And the resulting type would be either reply by string, where the list of by string is the resulting type of intersection, and reply is for error messages in case there's an error. Okay. Then what's problem with it? So firstly, Redis is untyped, or precisely speaking, everything is stored as strings. So then you can expect trivial type errors like this, that if you add, this set command sets the value of this key of the key sum string to foo. And then the command succeeds. And then if you try to add some string, which is string to another string bar, you get a type error. And it's just a trivial type error. But interestingly, you have everything stored as strings, including numbers. So actually, if you use the same command set and the same command as add, if you use the same command set and set some string to a integer printed as a string, and then use integer arithmetic on it, this will work. So that caused lots of confusion when we were playing with it. And also it has a peculiar pattern has a particular usage in some patterns that the same command is used both for creating the key value pair and for updating the value. So this command L push is like const, that it adds an element to a list. And then if you do L push some list bar, where it works regardless of whether bar exists or not. If it exists already, then bar is const to the list. If it does not, then this sum list key is just created. And also, like another interesting, curious example, this command length returns the length of the list. Okay, so now just now we have created this sum list, and then it has length 1. So if you try to measure its length, you will get 1. And then, okay, then if you set some, then for now you use the comment step to create a string called foo. And because it's a string, so actually your length doesn't work on it, so you get a type error. But however, if you just apply error length to something that doesn't exist at all, somehow the designers already decide to allow it to work, and it becomes 0. Okay. So that's a weird thing. So basically our goal is to try to create a small domain-specific embedded language around Redis, to hoping to ensure the absence of type errors. And so in that includes avoiding trivial type errors such as adding an integer to a string, and also try to keep track of what keys are created, what are not, etc. But however, at this point, actually, I haven't made a serious flaw in that. Actually, for the entire world, we were assuming the scenario where there's only one Redis server with one client, and whereas actually the usual usage for Redis is one server with many clients. In that situation, actually, the whole thing wouldn't work without serious complication. And we were not aware of that in the beginning, but somehow, anyway, that's all we did. Right. So what we did was to use an index monad, which to keep track of the status of the data store before and after every command. So this index monad is like ordinary monad. Apart from that, it takes 2 extra parameters. So recording the properties the states are, the state is supposed to satisfy. So this unit just doesn't change the state at all. So when you start with the state satisfying P, it also ends with the state satisfying P. And the bind operator takes the monad, which from state satisfying P to state satisfying Q, and function from A to N of Q of R of P, and gives you a computation when starting with the state satisfying P, and if it terminates, resulting in the state satisfying R. Okay. Then what we try to do is to store the status of the data store, recording in these parameters, and we hope these parameters to keep track of what keys are created and what types are associated, what types are each value of each key should be. Okay, so then actually we use internally we use the existing library Redis, and most of the Redis commands are wrapped in our embedded language. So our own monad Redis is simply something that wraps a Redis computation with 2 extra parameters P and Q. And so the simplest command is this one, ping. It does nothing but replying a message saying pong. And so then it can be read like this, that ping is something that takes the state satisfying access, whatever access is, and returns a state which also satisfying access. And then the implementation is simply calling the internal Redis version of ping. Okay. Then the next question is how to represent this state, the configuration of the state. And that is similar, I think most of you are familiar with this Haskell data types. But basically, when you define data type in Haskell, then it may have two, like this, it may have two readings. So it could be that 0 and sub, etc. are values having type net, and the net being a type has type star. But it can also be understood as that 0, sub 0, etc. are types having type net. And that allows you to use allow this term to be used in types. And some literals have a special, string literals have a special kind called symbol, which is a subkind of star. And then if actually in of kinds, then a list of edge, for example, or pairs, a pair of edge k are also kinds. So, for example, this int, const char, const bool, const it is a type having kind list of star. And say int char is a type having kind a pair of stars. And also, so this singleton list of a string key and the type bool can be a type of kind a pair of symbol and star. Oh, sorry, actually, there should be a list around. So sorry. It's a kind. The kind of this is a list of pair of symbol and star. Sorry about that. And actually, that is actually the type of the dictionaries that we're going to use. So, and then apart from that, we need to be able to define functions on types, functions taking types and returning types. And luckily now Haskell has already provided this functionality using type families. So for comparison, this one above is a usual definition of or, this disjunction. And then this type level counterpart is like this, that we can define a family of types or from a type of kind bool to another type of kind bool, and from another kind of bool, a type of kind bool, and a type of kind bool to a type of kind bool, which is defined like this. And okay, so now, so then we define a number of operations on dictionaries, and then this is one of them. So given a dictionary, which is a list of pair of symbols and star, and then take then another symbol k. So the function, the type function get tries to find the value this symbol k is associated with. Then, interestingly, now in type family, you can use this nonlinear pattern. And so when you find k, then you return x. Otherwise, you keep searching. And so it's not a difficult exercise to define other types, other functions, functional types like set, which alters, which assigns the pair k and x to which adds k and x to this dictionary access, and also delete field which removes k, which removes the pair with k from access, which we're going to use this later. And now considering embedding this comment field delete, which removes which basically kills a key, which kills a key in the data store. So it should start with the state axis and ends with the state which the pair with key is removed. But then now we have a problem that what should we put in this question mark? Ideally, we want to put key here, this key. However, the key is a value, so how do we smuggle it into type level? And then here we use another well-known trick called singleton type, a proxy, where a proxy of T is a type that has only one term, which is just which is just proxy. And so now with that, field can be defined like this, that takes proxy k. So now this k is smuggled into type level, and then the the resulting state can be declared as ditto of axis of k, and then this key is actually just a proxy. So when you actually call ditto, actually you can do this, and you call ditto with a proxy, and then you specify what the key is in its type, and that's a trick. And okay, so now, so when we actually embed commands, we try to keep track of like as I said, everything in Redis are encoded as let's say marshaled into strings when they are stored. But however, in our embedded language, we try to keep track of what they originally were. So we define types like string of, or list of, set of, etc. Now, for example, okay, this, so in Redis, everything is string. But however, in our embedded language, Redis, so we should be Redis. Sorry, we try to we allow this command set to take any A that is serializable, which means something that can be marshaled into byte string, and so then the set command takes the key and the value and set the key to that value. However, in the type, we see that it starts with the inner state satisfying axis, and then it finishes in a state where where the key k is known to be string of A. Then this A can be integer, can be bool, can be a float, etc. And so, for example, for another example, this command increment. It, as the name suggests, it increments the value associated to a certain key, provided that the value is an integer. However, now in its type, we do specify that the type of k in axis should be string of integer, meaning that it is a string which was converted from an integer. And the same similarly with include by float. And then, as I said just now, actually many functions in Redis have this peculiar behavior that it works when the type associated to a key is correct, or when the key doesn't exist at all. So then it is correct in our language, saying that okay, now we use a function testing where, for example, we define a predicate called list or an x, meaning non-existent of x of k, which is true when the type of k in x is either a list or it doesn't exist at all. Okay, and this is simply defined in the way you expect. And so then with a series of predicates like that, we can give types to funny functions like len, and from the type it's evident that it doesn't alter the state, but however it's applicable when the type of k is a list or when it doesn't exist at all. Okay, and similarly with this function lpush. And now for a slightly more complex type, so then this function sadd, which adds an element to a set. The type of this is that firstly the type of k in axis should either be a set or it doesn't exist at all. And then it takes a proxy denoting the key you want to add the element to, and the beginning state is axis. Then the ending state is axis, where k is now set of A, and A is a serializable type. And we also add think it might be a good practice that you can declare certain. You can declare that we can declare existence of certain pairs, certain pair of keys and types. So, so basically, this function declare doesn't do anything at all in computation. But in the type, it adds a new pair of key and type into Nexus. Okay, so that's that's about how it is. So basically, in summary, we define a small domain-specific embedded language that keeps track of available keys and types, and hoping to minimize the chance of having type errors when you run Redis programs. And then during that, basically, we were practicing using lots of recent extensions and type-level programming features in Haskell. And so we hope, so ideally we hope that the program can be constructed if it doesn't throw a type error. However, that's only the case when there's only a single client. Okay, that's it. Sorry for listening. Thank you for listening.
Hi. So I think Shin-Cheng is a little bit unfair to this work when we started out by saying, like, oh, this is a very simple thing, and so he was embarrassed for presenting it. Because I think in some ways we should say, this is an appealingly simple thing, and so we should be encouraging this to be presented so we can all try to learn from it. And I think there are a couple of things that I really enjoyed getting out of reading this paper. One was the extent to which seeing that even the sort of type-directed development tools that we have in a language like Haskell can be applied in a more realistic scenario to sort of to get these verification properties for our real-world system. But also because I find it illustrated both the complexities of dealing with real-world software and the complexities of using some of these features in Haskell in a way that deserves attention, and it maybe didn't entirely come out in the talk. And so I wanted to bring a couple of those things up. Hopefully this doesn't just come across as being mean. But the one that we did skip away by is the difficulty of using these sort of type-level symbols at both the type and the value level in a way that's syntactically appealing and easy for the programmer to use, right? And I don't think we had any of these sort of horrible proxy, proxy to foo declarations in the talk, but they show up in the paper and they're sort of emphasizing, like the singletons are great and they have all the type-level properties we want, but that doesn't make them necessarily easy to use. And similarly, in a couple of the early slides, when you look at the Redis commands, you have these I don't know, maybe they're wonderful, maybe they're horrible, but just lists of things that just work, right? You can just say, add a list of strings to a set, and it just goes off and does that, right? That's cool. And then you try to take that into Haskell, and you say, well, I have a list of these strings, and what does that list look like? Well, now, those things are themselves all symbols, and so they have disparate types, right? So now we need sort of heterogeneous lists to be able to express some of these Redis commands. And I don't know how much experience you have with that, whether you can say, like, whether real Redis programs translate easily into this style or difficult to translate into this style. And then one other question I want to stick in before I sit down is to say, in the paper you say there's this transactional part of Redis and you don't really talk about it. But I think the transactional part of Redis is really a great application for this tool because there is a little state machine working with the transactions, and it's again something that you get wrong, you get it wrong, it doesn't work. If you get it right, it does work. So I wonder if you can talk a little bit about where that's going.
Okay. So first thing I did that
Something else to say.
actually did. When I was playing with it, I did feel that things would be much simpler in a fully independent language. However, we are taking it as an exercise of how to do dependent type programming using the extensions that's what Haskell provides us. And I think there has been lots of debates about whether this approach Haskell is taking is good or not. And actually, I really don't. It is very not attractive to comment on that. I think both styles have its advantages. And that's what translation styles actually. Honestly, I don't know much about it. However, I think that's something we can try to do.
Do we have more questions?
David Whitman from Oxygen. how hard would it be to make this client safe when you only have clients that use your library, but multiple separate instances?
What's the question again? So how hard is it to make it work for a scenario where there are multiple instances of the same client?
Yes.
I don't know how that would be different from the general case when there are multiple clients with multiple different clients.
I mean, I assume the difficulty when you have multiple clients is that you can't track what the other clients are doing to the Redis feed. So if you have one client that is more privacy, and let's assume it has some basic safety things like not changing type of some string, some key. It should be more or less safe, I think. I'm not actually right, I'm just thinking out.
I'm not sure either. Can we talk about it all?
Okay.
That would be interesting to know.
Sorry. In terms of, I'm sure if you partition, the only way to do it would be to partition the key space, so each client is effectively seeing a private copy of the.
But I mean, one of the use cases of Redis is to have like a cache that's shared across several instances of server or something at your Redis client. And it would be a bit kind of like to have different keys. So you have to have shared keys in the case.
Simon Peyton-Jones, Microsoft Research. Do you want to just comment a bit about Garrett's point about how convenient or inconvenient it is to program in this type version of Redis versus the sort of previous version? How painful are all these proxy arguments? And the sort of second half would be, if you could dream, then what would you like it to look like? And you can think of a language extension that would make it easier. Up to, I suppose, and including making Haskell into a full spectrum independently typed language, but perhaps something less ambitious than that would serve your purpose. It's almost just notational clutter that you were referring to, isn't it?
Okay, I wish to have something that feels more like defining type-level functions than this type family thing. But I think it's probably just a syntactical difference.
But Garrett's point was that the client, that's for you, the author of this package. Garrett's point was the client of your package, right, has to write all these proxy things, and that's painful. Is that a problem in practice that you found?
I don't think that's much a problem. And it's just some. I think that the difference is merely syntactical in most cases.
Okay.
I have a question. So, part of the point of doing this kind of exercise is to catch errors. Did you find when you were doing experiments that it gave you errors when you did something that was ill-typed? And what did they look like? Were they even readable?
Okay, in the small experiments we tried, it did happen often that we tend to forget whether variable is declared or not. And also because some already have this thread pattern, so its behavior is a bit different from what we expected. So in that case, this thing helped. But usually, maybe the type error takes some time to reduce to decipher.
Right, so there's a gap there. Any more questions?
David Miller, Standard Chartered. Did you find you gained any additional functionality from having all that type level information? So for example, we do a lot of stuff with type relations, and we can automatically project down to only the columns which are used, because we have type information about what's used in each function. Did you create anything like that for your Redis stuff?
No, nothing has been like that so far. Actually, in the type, the programs we allow capture are a subset of actually have subset of these programs. And actually, in some cases, we have to restrict its functionality. For example, this sadd function, it's the Redis version actually allows you to have an indefinite number of arguments. You can have multiple elements to a set in one command. We find that it's implementing this